All right, let's start with this. So find the point 5 comma 4 pi over 3. So we did that. Let's do it again real quick. So remember how this works. This is a new way of locating points, isn't it? So let me make sure we're clear. So the old way was the rectangular system, x-axis, y-axis. They say stuff like, find the point -3 comma 2, please. And what do? We start at the origin and we go back 3, because the first one's the x, second one's the y. You know this quite well. This is the old system, which you know like the back of your hand, right? Back 3 up to, there's the dot, -3 comma 2. If I can write this a little better. -3 comma 2. They call that the rectangular system. Rectangular. Why do they call that the rectangular system?
It makes a rectangle.
Yeah, it makes a rectangle as you move. Go boom, boom. It's part of a rectangle. It's half a rectangle, isn't it? So you move perfectly sideways and then perfectly up and down. That's the rectangular system. Well, now we're talking about a new system. You could locate that same dot, right? If this was a military operation and they said, you know, the place we want to shoot the artillery is right there at coordinates back 3 up 2. You instead could specify that same location by giving an angle to aim at, starting here at 0 degrees, and turn the cannon to this angle, right? So you want to aim in that direction. So however much that angle is, I don't know, I'm just guessing. Maybe that's, I don't know, what does that look like to you guys?
135.
Yeah, maybe 130, maybe a little past it because it's not right on the diagonal, huh? It's back more than it's up. You know what I mean? So maybe a little, yeah, like 140 maybe, something like that. I'm just guessing, you know, about 140 degrees. Bless you. 140. Turn the cannon to 140 degrees and then shoot out how far. That's the R, right? That's the radial distance, right? That's the same dot, same location, given in another way, right? So it's another system to locate the dots on the plane, the XY axis, the R theta. It's using R, using an angle and a rate and a distance to shoot out from the origin. Okay, how could we find the R and the theta, by the way? Since I made up this example, a little good introduction, little review of what you already know.
Tangent inverse.
Yeah, how do we find the theta? Tangent inverse of the y over the x, b over a, j over I, whatever you want to call it. We all know it well now, right? Tangent sine over cosine, it's the vertical over the sideways, huh? Right? But, good job, Chanel, as I was just reviewing with my son last night. They've got to both be positive, right? You can't have one of those be negative. Remember that? Really important. We'll be doing a bunch of that in this chapter. We have been, right? You're getting probably really comfortable with that. You got to. So I'm not going to go. So here's the y, here's the x, right? No, sorry, backwards. Anyway, there's the x, there's the y. So I'm going to go 2 over -3. No, I'm going to make that positive 3, even though it's negative. When you do the tangent inverse, you make it positive. Why? Because I want to put it in the first quadrant. Because then I get a reference angle. Remember, because all those weird things about the tangent inverse, and it'll give you weird answers because of all that weird stuff. So instead, I just say, look, here's the easiest way. Just make it all positive. You'll get a first quadrant answer, because that's, remember, all students take calculus. Everything's positive in the first. So if you make that all positive, you're going to get a first quadrant answer between 0 and 90. And then you just say, okay, but that's really in the second quadrant, as we can see. It's really in the second, and then you just do the reference angle thing to find what the actual angle is in the second, right? So if I did that, if I hit tangent inverse, you guys already ahead of me? What's tangent inverse of 2/3? I'm in the wrong mode. Got to be in degree mode. I'm in radian. I can tell by the weirdness of the answer. All right, I got 33.7 degrees. So this angle is clearly not 33.7, right? It's more than 90. So what do we do? What's the 33.7? It's the reference. Yeah, you all know that. It's this. It's from the nearest x-axis. That's 33.7. So how do we get the actual angle from 0? 180 minus it. Yeah, which would be 146.3. So it's even more than 140. It's like about what we thought. 140, it's 146.3. So aim the cannon at 146.3 degrees. And how far do you shoot out the cannonball to hit right here? What's the R? How do we find the R? The radial distance. What do we do? Yeah, it's always the hypotenuse of a right triangle. Remember, every vector, I is sideways, J is up, or X, Y, same thing, is a right triangle, isn't it? So this R here is the hypotenuse of a 3, 2, negative 3, but who cares? Going to square it anyway, huh? Negative 3, 2 right triangle. So the R is the square root of a squared plus b squared. It's hypotenuse of a right triangle, huh? Right? So it's going to be the square root of 3 squared plus... I didn't even make it negative 3, because who cares? It's going to be positive 9 anyway. 9 plus 4, root 13. So that's the same point if you say root 13, comma, 146.3, the r theta. That's the same exact dot in the r theta system as negative 3, 2 is in the xy system. Is this making sense? You're getting the big idea. It's a different coordinate system for finding locations. Instead of giving an x, y, back 3, up 2, you take the cannon and you turn it to 146.3 degrees. Then you're aiming at that location. You shoot out a distance of root 13, whatever that is, your calculator will tell you, 3 point whatever. And boom, you'll land on the exact same dot. Those are two ways to say the exact same dot. Does that make sense?
It's kind of like the 12-hour clock and the 24-hour clock.
Yeah. Oh, I like that. Nice. Yeah, like military time. What would they say is one in the afternoon? Military time. 1,300 hours, right? Because they want to be more clear. They don't want confused. They don't want you to say, be there at 1 o'clock to the troops, and they show up at 1 a.m. instead of 1 p.m. They don't want that confusion. So they say 1,300 hours, which means past 12, right? Yeah, good. Two ways to say the same thing. We would say 1 p.m. The military would say 1,300 hours. It's the same time. It's the same exact time in two different systems, isn't it? This is the same exact dot in two different coordinate systems. So polar is r theta, and rectangular is xy. Okay, but here's the trick. There's more than one way to say that same location in polar, isn't there? In other words, I could say, well, what do you mean? There's only one way. It's root 13, 146.3 degrees. No, I could actually add 360 to that angle, couldn't I? That would be another loop round, but you'd still be, take the cannon, turn it all the way around, you're still pointing in the same direction, huh? That's going to be the same dot said with a different angle, isn't it?
You said polar is the theta and rectangular is the what?
Rectangular is xy.
Oh.
Yeah, rectangular is xy. Polar is the r theta. Yeah, so you can say that's the trick with the polar system. There's more than one way to say the same dot, isn't there? And there's more, not just that. What else could you do? What else could you do to say that same dot with different r or different theta or both? What else could I do? How could I shoot and hit that same spot with a different r and theta? Really, no idea at all?
Is it a Morse theorem?
Oh, no, not that. Not that, no. Couldn't I just add another 360?
Oh.
Right? Or, couldn't I aim the cannon this way and do what? And backfire. Make the root 3 negative, remember? And I could say this angle is negative or positive. So there's all kinds of ways. There's all kinds of ways to say the same location in polar. Not in rectangular. There's only one way. Back 3, up 2. That's it. So that's what's weird. In rectangular, there's only one way. In polar, there's several ways. All right, that's what this problem, number 6, is all about. It's saying, let's find a bunch of different ways to say that same dot. That's what it's all about. So let's start, first off, with finding the dot. It says it's 5, 4 pi over 3. So let's find A, B, C, or D. Which one of those is that dot? So I don't look at 4 pi over 3 and think very naturally about that. I would just stick in a 180 there for pi and use my calculator. So that would become 4 times 180 over 3, it's 240. 5, 240 degrees. So which one of those do you think is A, B, C, or D is 5, 240? So you take the canon and you say, I'm going to turn it to 2. Here's 0. I'm going to turn it to 2. Here's 90. 240. Here's 180. Here's 270, as you know. Where's 240? About like here. Huh. That right? We take the canon and we turn it all the way. Right, we take the cannon, aiming at 240 degrees, and then we shoot out a distance of 5. Boom. A distance of 5 in the direction 240 degrees. So which one is it, A, B, C, or D?
C.
C. Clearly and obviously, C is the answer. Okay, now having done that, now they're going to say, okay, good. You got it. Now, let's play the how many different ways can you say that same dot game. So on part A, they're going to say, all right, what are the coordinates of the point? You know, same, the point, same point, same dot, this dot, this exact dot, but we want you to say it a little differently. We want you to say it with an R that is greater than 0. What's that mean, greater than 0? Positive or negative? Positive. So it's positive, which... You know, that's what we did. That's not different. That part's not different at all. We already used a positive R. But look at this. We want a theta. Can you read that?
It's less than 0.
We want a theta, yeah, less than 0. What do we call that? Negative. We want a theta between negative 2 pi and 0. We want a negative theta, please. Can you say that same dot using a positive R and a negative angle? How do you say that same dot using a negative angle? Who's got the answer? So tell me, so what's the answer? Very good. Negative 120. Is everybody seeing that? Let me go through the details. Correct, right on. Yeah, because you got to find this angle, huh? Negative means start at 0, turn down instead of up, as you know, right? And if you're going to 240... yeah, that's going to be down 120, right? Down 90 and 30 more, right? Yeah, and you just subtract 360. You just take the original 240 and just say, oh, okay. Take that original 240 and just subtract 360. You get the angle minus 120. Because that's the same. Whenever you add or subtract 360, you're pointing at the same spot, aren't you? Right? If I aim at Windy and then I turn 360 this way or turn 360 that way, I'm still aiming at Windy when I'm done, right? So, yeah, so negative 120. So that'd be the first answer. The first answer is 5, negative 120. Oh, they probably want you to say it in radians, huh?
If it wants it in radians.
Yeah.
Negative 2 pi over 3.
So we got to change it. Yeah, so you got to take that negative 120. You know what I would do? Here's what I would do. I think a lot of this would be, right, here's 240. Right, there's 240. I would go, okay, there's where our point is, right here. So now I'm saying that is, so that's what, 4 pi over 3. So I would just say take 4 pi over 3, and what do they want me to do? Just subtract 2 pi. You know, because that's what we're doing. Just do it all in radians. Do you see what I'm saying there? So, well, maybe that's not easier. I don't know. I thought it would be, but maybe it's not.
Negative 2 pi over 3.
Whatever you want. Because you might think, well, wait, Mr. Didn't we have negative 120? Yeah, just take the negative. How about I go back? I changed my mind. Let's take the negative 120. Either way is right. Whatever's easier for you. I'll take the negative 120. How do you change degrees to radians? Remember what I learned anyway in Chem 3A. You're taking Chem 3A, right? Chem 3A is where I learned how to change units. Not any math class. It was Chem 3A. I learned that the units cross-cancel just like fractions always do. So 120 over 1, you put 3, no, not 360, 180. Huh, what am I doing? 180 is what we convert with. 180 degrees is pi radians, isn't it? How did I know to put the 180 on the bottom and not the top?
You want to cancel.
Because I want degrees to go away and change into the radian system. Do you see that? That's what I got when I took Chem 3A. That was the most valuable thing I got out of Chem 3A. I don't remember a lot else. And my daughter, I helped my daughters taking chemistry and physics, all that stuff. She asked for chemistry help. Well, she doesn't ask. From the beginning, I said, I remember nothing from chem. Physics is a little more mathematical. So that one I like doing, and I can help her with that. But chemistry, I took Chem 3A, 1A, and 1B, and remember nothing, pretty much. Yeah, sorry, nothing. So nothing in my noggin. But what I do remember is changing units. Changing units. Yeah. So whatever you want to get rid of, you put down below, and they cross cancel. So those degrees cancel out like that. Right? So we get negative 120 pi over 180. Reduce that fraction. Right? Multiply, get rid of the zeros. So minus 12/18 pi divided by 6. Top and bottom, minus 2/3 pi. Minus 2/3 pi.
Mr. Hearn, you could just go to the 120 on the circle and make that number negative 2, right? The radian.
Go to the 120 on the circle.
Yeah, and then you see how it's...
That's genius. I like that, Kevin. Yeah, did you see his plan? So much better than my plan. Yeah, look at that. Look at that. Do you see what Kevin, let me show everybody. Everybody see, you probably already see it, but let me just say it real clear in case you have it. Yeah, nice. I didn't think about that. Yeah, because we said, all right, boom, because 240, that's negative 120. We knew it was negative 120, and I'm all thinking, okay, what is that radians? Kevin's like, look right here. 120 is 2 pi over 3. It's right on the diagram. So it's negative 2 pi over 3. Yeah, good job, Kevin. There it is. That's better. Yeah, just do that. Just do that. So, all right. Here we are. So that's 5 comma negative 2 pi over 3. Excellent. Yeah, let's use that for the next one too, or whenever we can. All right, let's do B. So we're going to have 4 different ways to find that same dot. B. What are the coordinates of the point for which? Now, in part B, they're saying r is less than 0. What does that mean? Negative. So that's r is negative. And then theta is just normal. Back to the normal theta between 0 and 2 pi. We'll just stay with the same, whatever it was, 4 pi over 3, the original one. So now we're just messing with the r, not the angle. Well, that'll make us change the angle, actually, won't it? So if we're going to make the r negative, let's just focus on that first up. They're saying, hey, find that same dot with a backfire. That's what they're saying, huh? R negative. That's when the cannon backfires. Right? So let's go look at our diagram. That's a mess. Let's get a fresh one. Get a fresh unit circle. So it's good to have the unit circle and use it throughout. Okay, so here's my dot still. The dot is really right there at 240 degrees, 4 pi over 3. There's the real dot we're hitting. We want to hit it now with a backfire. So what angle is the backfire angle?
Pi over 3.
Yeah, you can just see it, huh, on the diagram. It's right there. And it's right on the, yeah, this is beautiful. It's right on the diagram. No converting, nothing. Just that's the opposite direction, right? So pi over 3, it's already there in radians for us. No need to convert nothing, to use bad English, anything. And if you aim this away and then backfire 5, you'll hit the same dot, won't you? Everybody with me? So it's negative 5, backfire 5, while you're aiming at pi over 3, 60 degrees. Everybody good with that? So this would be backfire 5 while you're aiming at pi over 3. Notice we gave them a positive angle, that's what they wanted, a positive angle and a negative r, hitting the same exact dot. So we go on to part C. You can kind of see it down here. Part C says, now give me a positive r greater than 0. Maybe I better go to a fresh screen. They're saying now r greater than 0 and an angle between 2 pi and 4 pi. Can you see that? I'll bring it up here. An r less than 0. No, greater than 0. Positive. Normal. So that's positive. Normal. But they want theta between 2 pi and 4 pi. In other words, that's more than one rotation, isn't it?
So add a 2 pi.
Yeah, it's just add a 2 pi. It's no big deal. Oh, let's go back. So they want the same location, but instead of using 4 pi over 3, just add 2 pi. Just add an extra rotation, huh? No big deal. How do I add 2 pi? What do you got to do?
6 pi over 2.
Yeah, common denominator, put it over 1, right? And so, here, I'll bring it back. So add 2 pi. So we're going to, where are we? Here we are. So we're going to take 4 pi over 3. We're going to add 2 pi. So you know how to do that. Put it over 1, top and bottom by 3. So it becomes 4 pi over 3 plus, and then you multiply top and bottom by 3, 6 pi over 3, add that up, 10 pi over 3. So there's your angle, 10 pi over 3. So the answer they want for part C is the R is still the same, no change on the R, 5, but now the angle is 10 pi over 3. That's the same angle, it's just an extra rotation. Is that good? Wendy?
So how do you know that 10 pi over 3 is between 2 pi and 4 pi?
Because I added one rotation. So being between 2 pi and 4 pi is more than one rotation, but less than 2. Good clarification. Everybody see what Wendy's asking? That's how I know, right? Because what does it mean to be more than 2 pi? You're more than one whole time around. But you're less than 4 pi. You're not more than 2 times around. You're more than 1, but less than 2. And I just took the first one and added one rotation. So I'm between 1 and 2 rotations, which is what they want.
So I was just thinking if you took the 3 and divided into that 10, it'd be 3.
Oh, or that way. You're totally right, yeah. 3 into 10 is 3 something. It's less than 4. Good, another way to prove that. Yep. Good, all is well. Allowing that. All right, let's try number 7 here. So first off, find out which one of those is 4 comma 3 pi over 2. So I hope you have the units, or well, you have the little pie charts, the little polar graphs before you, right? So just look down at the polar graphs. Can you see those? It's tiny print for my old eyes anyway.
So weird.
Yeah, one to squeeze in. You got 6 on the front, 6 on the back for doing your homework and stuff. So find 3 pi over 2 on there. And shoot the cannon out a distance of 4. Find the dot. See how the paper works? Did y'all find that? So if you aim the cannon, here it is. I'll paste it here. At 3 pi over 2, that's straight down, huh? 3 pi over 2 is aiming straight down. Now, how far do we go? What is it? 4. So you see what you shoot the cannon out. 1, 2, 3, 4, right there. So everybody see how the circle that we're doing, each of those circles is radius is 1 more than the last one. Right? So you aim down at 3 pi over 2 and you shoot out 1, 2, 3, 4. So that's this location right here is 4 comma 3 pi over 2. Good? Let's go back. So it's that one clearly, D. That's easy. Now, question A, what are the coordinates for r greater than 0? Yeah, I'm going to jump, what should we do? I'm going to jump, how about let's do B. Let's just do B and we're out of here. We don't got time to do the whole thing yet. Jump down to B. B says, hey, give me an R. Let me write out B for you. Give me an R less than 0 and theta between pi and 3 pi. Yeah, try that. R less than 0. Yeah, that's a hard one actually. Oh, they're being tricky. Yeah, they really are. I'd be impressed if you could get that one. That one's a little tricky. So they're saying, all right, redo this thing now. And go to the polar paper here. We want an R less than 0 and a theta, between pi and 3 pi. All right, so first off, if they're saying R less than 0, what's less than 0 mean? Positive or negative? Negative. Less than 0 is negative, isn't it? So they're saying they want an R that's negative, which means they want a backfire. Everybody good with that so far? That conclusion clear in all of our minds? So which way do we need to aim if we're going to backfire and hit that dot?
Pi over 2.
We got to aim up, don't we? If we're going to backfire and hit that dot. Clear so far? They want a negative r. So I got to aim up. Now, can I aim at pi over 2? No, because that's not between pi and 3 pi.
You have to add a rotation.
Everybody seeing that issue first off? Everybody first seeing why? Why can't you just say pi over 2 is my angle? Because they specifically said the lowest you can go is 1 whole pi. Don't be going down to half a pi, which is pi over 2. We want an answer between 1 pi and 3 pi, please. So how do we do that? Pi over 2 is where it's at. What do they mean? Can they do that? They can do that. What do you got to do? Just add a rotation. Whenever that angle, I mean, you're right. We need to point up. That's true. But with an extra rotation. So we take pi over 2 and we just add 2 pi. Does that make sense? So if you add 2 pi, put that over 1, common denominator, top and bottom by 2, going to get what? Pi over 2 plus 4 pi over 2, which is 5 pi over 2. 5 pi over 2 is what? What is that as a... What's another way of saying 5 pi over 2? It's 2.5 pi. Does everybody see that's 2.5 pi? Right? Remember how to change between mixed numbers and improper fractions? We all good with that? 2 goes into 5, 2.5 times. Right? Remember your long divide. Or you can double check. Multiply and add. 2 times 2 is 4, add 1, 5 halves. Same thing. Right? So my point is, why am I saying that? Because that shows it's between 1 and 3. 2.5 is between 1 and 3 pi. Isn't it? I've done what they asked for. They said, get it between 1 pi and 3 pi. So I said, okay, how about 2.5? That's between 1 and 3, isn't it? So 2, and that's still straight up, isn't it? Because it's just pi over 2, add a full rotation. So it's still pointing straight up. It's still straight up. So 5 pi over 2 is my angle pointing straight up. But to hit this dot here, what do I got to do? When you're aiming straight up, how do you hit that dot behind you? Backfire 4. Negative 4, comma 5 pi over 2. That's the same dot pointing straight up, backfiring 4, and the straight up, instead of saying pi over 2, we added a rotation, 5 pi over 2. Guillermo.
Just added pi to 3 pi over 2.
If you just added pi, remember what pi is. Pi is a half a turn. So you'd be pointing down. We don't want to point down because we got a backfire. They told me R has to be negative. So I can't be aiming at the target if I'm going to hit it with a backfire. You tracking with me? If you add, see where we really need to aim is straight up. If we're going to hit this dot with a backfire, we have to aim up. If you add pi to that, you add half a circle. Remember, pi is halfway around. You suddenly are aiming straight down. We need to add 2 pi. So we're still aiming straight up when we're done.
If you add pi to that, you would end up at the same place.
So if you start with pi over 2, which is up.
No, 3 pi over 2. And then add pi.
Yeah, that would work. Yeah, 3 pi over 2, add pi. That would work. That would work. That's right. Yeah. Yeah, so we always add 2 pi because that's a full rotation, right? You get aiming where you want to aim, and then you add a full 2 pi. Yeah, good. Or your other way would work too. Number 11, 6 comma 90. So we're going 6 comma 90, change to rectangular. So they're giving it to me in r theta. They're giving me coordinates in r theta. And they're saying, can you change that to rectangular, please? All right, how do we do that? How do we change from polar to rectangular? Same as for vectors. Exactly the same. This is where it really won't be hard for you because it's just exactly what we were doing before. What do I mean? Remember how they would give us an angle and a magnitude for vectors? And we would go magnitude of the vector, cosine of the angle I, plus magnitude of the vector, sine of the angle J. Remember that? Remember how we would change to IJ when they gave me a vector's length and an angle? Well, that's what they're doing here. R is the length. Theta is the angle. And they think, yeah, but we don't have I and J. Right, but what's I? X, J is Y, huh? That's my X and my Y in the rectangular system. So in other words, the X is always going to be R times the cosine of theta, and the Y is always going to be R times the sine of theta. Just like for vectors, it was magnitude cos theta and magnitude sine theta. Now it's R cos theta and R sine theta. Same thing. So it's just going to be 6 times the cosine of 90 degrees, 6 sine of 90 degrees. And let's go to the unit circle, our favorite trigonometry tool, our trigonometry friend. 90 degrees is right up here. Cosine sine. Cosine is 0. Sine is 1. So 6 times 0, 6 times 1. That's 0, comma, whoop, not 1, 0, comma 6, huh?
Would it be 6i?
No, this isn't a vector. It's just x, y, so no i's and j's. It's just 0, comma 6. Done. We changed from polar to rectangular. From r theta to x, y. Same dot. Same dot. So everybody see that? It's exactly the same as vectors. Which is nice, because when you get to the final, which is only like 2 weeks from Wednesday, huh? Is that right? Yeah. 2 weeks from Wednesday, we have the final. We have all 5 chapters all at once. It's nice. This is like 2 chapters in one. It's the same thing. You get those vector questions. You get these. They're going to be the same. Same exact thing. If you got an angle and an R or an angle and a vector magnitude, it's just R cos, R sine. Vectors, polar coordinates, all the same thing. 0, 6. Let's see that on an actual vector. A polar graph. Let's find the original. I think it's helpful. What was it? It was 6, 90. Let's do the canon thing. So turn to 90 degrees. Where's 90 degrees? Straight up. Right? Turn the canon straight up. 90 degrees. Okay? And then shoot out. I'm finding 6, 90. Shoot out 6. 1, 2, 3, 4, 5, 6. Right there. So there's the point. 6, 90 degrees. You agree with me? Aim the cannon at 90 degrees. Shoot out a distance of 6 lines. So there's the dot we're talking about. How would you say that same dot in x, y? That same dot is over how far, up how far?
0, 6.
Over 0, up 6, isn't it? Isn't that same dot over 0, up 6? Mm-hmm. And it's 90 degrees, shoot out a distance 6 in the r theta system. And that's the answer we got, huh? 0, 6. See how it's telling us the truth? That's 2 ways to say the same location in the 2 different systems. Right? 0, 6. So by doing r cos and r sine, just like for vectors, magnitude cosine I, magnitude sine j. I and j are x and y, aren't they? See how this stuff's all the same? You get your answer, 0, 6. Hey, by the way, one more thing. I don't want to give you rules without reasons. Why is that the case? It's super simple. Super simple. Let me just show you. If you had some dot, right? If you had some dot, there, let me get rid of that for a minute. You had some dot, and you were at some angle theta, and you were out some distance r. If this was the point r, comma theta, that would mean you turned the cannon to the angle theta and shot out a distance r, right? How could you change that to rectangular? Just make a triangle right there, huh? How far over is x? How far up is y? How would you find x and y? Yeah, SOHCAHTOA. I'm just showing you why these formulas are true. Right now, you don't need to know this, but I hope it's satisfying. I want you to see why these are true. Why is this the way you change? Well, just think about it. If you turned to some angle theta and shot out a distance r to find the point right here, r theta, and you wanted to change it to xy, you could just come straight down and straight over, make a triangle, a right triangle, because it's straight and straight, So right triangle, straight down, straight over. Right triangle, we can use SOHCAHTOA. Let's, this is the adjacent side. This is the opposite side. This is the hypotenuse. So if I take the cosine of theta, which is adjacent over hypotenuse, I get that. How do you solve for x? A silence falls over the crowd. I'm not sure why. How do we get x alone there?
R times cosine theta.
Just multiply by r, right? Boom. Gonzo. X is what? R cos theta. See? The x is r cos theta. See where that comes? It's just a simple little right triangle. Of course it's r cos theta. And how do we get the y? Y is opposite. Opposite over hypotenuse. What's that? Sine. So SOHCAHTOA, sine is opposite. So the sine of theta is y over r. How do you solve for y? Multiply by r. What is y? R sine theta. So that's where it comes from. You don't need to know that. I'm not going to test you on that. But I want you to see we're not just making this stuff up. That's pretty clearly true, isn't it? That's how you get the x and the y. R cos r sine. Just imagine a little right triangle. That converts us between the r theta system and the xy system, huh? That's how we convert. Okay. So again, they're giving me r theta. They want you to change to rectangular. So do that one. So this is r theta. So what do? It's going to be r x. X is always r cos theta. Y is always r sine theta. Just like for vectors, right? Magnitude cos theta I, magnitude sine theta j. Same thing. So it's going to be negative 5 cosine of 3 pi over 2, negative 5 sine 3 pi over 2. Good? Just like for vectors. So I keep saying that because I want to help you in 2 weeks, when you take the 2 weeks from Wednesday, when you take the final exam, that you get the vector. You're going to get these same questions with vectors. So it'll be the same thing. Just magnitude cosine theta I, magnitude sine theta j. So then what is that? Minus 5 times. Now we got to go to our favorite trigonometry friend, the unit circle, and say, all right, 3, what's our angle? 3 pi over 2. Where's he? He's down here. 3 pi over 2, right? So we're talking cosine sine. Cosine is 0. Sine is negative 1 at 3 pi over 2. So cosine is 0. Sine is negative 1. So what's that? 0 comma positive 5. Done. That's the xy. We good there? Questions on doing that? Changing from r theta to xy? Just r cosine, r sine. All right, I'm going to move right on if you're good, if you got that copied down. Now, is a strong bridge between the rectangular world and the polar world. So now on number 13, they say, okay, now let's start with a rectangular point, 3, negative 3, that's x and y, and go the other way. Change to r theta, please. Change to polar. R theta. Type in order pair, radians. Yeah. Whoop. So there we go. So how do we go the other way? How do you go from like an xy to an r theta? Guess what I'm going to write right here for you? I'm going to write exactly what I wrote first time. Exactly the same as vectors. We did this exact thing for vectors. What do I mean? What if somebody gave you 3i minus 3j, and they said, hey, change that to an angle and a magnitude, please. See, angle magnitude basically was r theta. That was basically polar. That's the same thing. Remember how we would do that? How do you find the angle? How do you find the angle first off? What do you do? Tangent inverse. Yeah, you guys are pros at this. Tangent inverse of what? Negative 3 over 3, right? Good. Must be positive. Everybody remember that. Remember? Make that positive over positive. Why? Because then we get a reference angle and then we draw it. And then, so what do you get? You hit the buttons on the calculator, 45 degrees. Now, but then you have to draw where it really is. So where is this point really?
In 44.
Right 3, down 3. Yeah, right there. There's the point over 3, down 3.
315.
So yeah, so when we got 45 degrees, remember this is always a reference angle, it's not the real angle. Right? Am I going too quick? It's exactly what we did for vectors, right? Same thing. Theta is tangent inverse of positive y, it's positive y over positive x. Get the reference angle, then draw the vector, draw the r theta thing, same thing. And find the actual angle from 0. Well, where's the 45 go? It's a reference angle. What does that mean? Reference. From the nearest x-axis. I hope you know. I'm not into words too much in math, but that's one word that really helps you know what to do. That's the only time I'm into words. Reference means from the nearest x-axis. Means from there. 45 degrees from there. So now how do we say how far it is as an actual angle from 0 degrees? There's actually two ways. You could say negative 45. Yeah, why don't we just say that? That's negative. Or you could say, I think it's 315. Either way, they're both right. Don't say 45, though. Say negative 45 or 315. If you just say 45, you're saying it's up there. That's 45. That's positive 45. This is actually negative 45 down there, huh? Ours is negative 45. See the difference? Ours is negative 45, not positive 45. It's 45 down from the x-axis, so it's negative 45. So I'm just going to go with negative 45. So negative, actually, you know what? I think they won't let me. What do they say? Yeah, so we can't say negative 45. So just take your negative 45, or actually they want, let's go to the, let's do the Kevin plan and just go to the unit circle. What am I doing all this messing around? It's right here, isn't it? Right? Everybody get 315, 45 down right in the middle. It's 7 pi over 4. They want radians anyway. I don't want to convert, do all that mess around. It's right there. 7 pi over 4. Is that good? That'd be the easiest thing. Just say 7 pi over 4. Good. So it's 45 degrees and halfway down, right in the middle going down. 7 pi over 4. We'll use the Sisk method, Kevin's last name. We got the Sisk theorem going on. I like it. It's a good observation. So what was that? I already forgot it. 7 pi over 4. All right, so 7 pi over 4 is our angle. How do we find the r now? We're almost there. You're supposed to say r theta. We got the theta. The angle, we're changing from, remember what we're doing? We're changing from rectangular over 3, down 3. That dot, we want to say it as an angle. 7 pi over 4. And now r. So if you turn the cannon all this way to 7 pi over 4, and you aim it this way, how far out do you have to shoot? What radial distance to hit that dot? Same as vectors. Exactly the same. How do you find the magnitude of the vector? It's the same as r. R is the length.
Yes.
What do you do?
Square root of a.
Yeah, it's the hypotenuse of a right triangle. Right? The vector length, the r, it's always right because it's over 3, down 3, isn't it? Right triangle. You want to know this length? This r here? Square root of a squared plus b squared, just like it was for vectors. See how it's exactly the same as vectors? So this is not new. 3 squared plus 3 squared. I don't care about the negative, just being squared. 9 and 9, 18. Square root of 18, you simplify that. That's 9 times 2, 3 root 2. There it is. 3 root 2, comma 7 pi over 4. We good? And just get your angles right off the unit circle, which you'll have before you. 3 root 2, comma 7 pi over 4. Questions on that one? So we changed. So how do you change from xy to r theta? Exactly the same as vectors. The angle is the tangent inverse of positive y over positive x, and then that's a reference. Find the actual angle, and then the r is hypotenuse of a right triangle, just like vectors. Square root of a squared plus b squared. R and theta, same thing. All right, same thing. Let's try it one more time. Change, so this is x, y, change to r theta. Let's do it again. Use your unit circle to guide you. It always does, yeah. So r, well, I'll start with the r. Square root of a squared plus b squared. So that'd be negative 1 squared plus negative. You don't even need the negatives, you know, it's all going to become positive anyway. Who cares? 1 plus 3. Square root of 4. That's nice. R is just 2. So R is just 2.
Now, how would you know if that's a positive or a negative 2?
It's always positive. It's a radial distance. There's no plus or minus. We didn't put the root over both sides. The root was already there. So that's the difference if you're wondering about that plus or minus. That's when you bring in a brand new root that wasn't already there and you put it on both sides. This one was already there. It's always positive. It's a radial distance. It's a distance. Distances are always positive. Okay, so now, secondary, let's get the theta. How do we do it? Tangent inverse of the positive root 3 over positive 1. What does that come out to be? 60 degrees?
Yeah.
I think, right? 60? So then just go to the unit circle. Just find 60 degrees on the unit circle. That's the easiest thing. Let's don't mess around with conversions or any of this business. We'll use Kevin's method. Just go to the unit circle. Find 60 degrees right here, which is pi over 3.
You have to go the opposite way, though, because it's in the other quadrant.
Oh, yeah, you're right. Thanks. So 60 degrees, you're right, I forgot about that. And then you got to draw it. Yeah, I'm messing up too. So there's the reference angle. That's just the reference, huh? The actual, how do we find the actual angle? Yeah, don't make the mistake I make it. You got to locate the actual point, huh? Yeah, back 1, down root 3. It's in the third quadrant, huh? So it's that same angle in the third quadrant. Back 1, down root 3. Really all you need to know is the quadrant. Is everybody good with this? Remember how we did this for vectors? It's the same thing. So you just do the tangent inverse of the positive y over positive x. Get the angle, but no, that's a reference. That's not the final answer. Then draw your actual vector or your polar xy thing. See what you're in the third quadrant and go, okay, I need 60 degrees. I need that way, but in the third quadrant. So then you just say, it's that one, huh? That is exactly halfway around. Does that make sense? So it's 4 pi over 3. Everybody good with that? See how I did that?
Question, on your final, are we going to be allowed to use the calculator for all of them, or is it going to be like no calculator and then calculator?
Yeah, there'll be some no calculator and some calculator. Yeah, there'll be both. You'll see there's a practice final out there. It's just like that. Basically, everything the rest that we've had no calculator throughout the semester will be no calculator in the final. Be same-o, same-o. So, everybody see that? 60 degrees? Everybody good with that? So that's the same halfway around. So 4 pi over 3. So our answer then is 2, 4 pi over 3. We good? Changing from xy to r theta. Okay, so now they want, so that's an equation in the xy system. Change to r theta equation. So now we're not just changing the coordinates of a single point, where they're not just giving me one dot and saying change that dot to the other system. They're saying change the entire equation. It's actually probably easier though. Here's how do you convert between the two worlds. Here's what you're going to want to have in your 3x5 card. X is r cos theta, y is r sine theta. Right? That's what we used a minute ago, right? X is r cos theta, y is r sine theta. And then just take that right here, plug it in for x. Take this right here, plug it in for y. And what do we get? 8 times r cos plus r sine equals 10. Everybody see 8x became 8r cos. Y is r sine equals 10. Everybody good so far? I just plugged in for x, r cosine theta, plugged in for y, r sine theta. So now I've changed from x, y to r and theta, haven't I? Last thing is notice they want r alone. So they want r alone. So how do I take this little equation and get r all by its lonesome? No, if I subtract it, then there'll be r's on both sides. Nope, factor out the r. So factor out the r. Everybody see that? Factoring, just factor out the r as a common factor. And then what do you do to finish getting r alone? Just divide by that whole thing. 8 cosine theta plus sine theta. Divide by 8 cosine theta plus sine theta. Wham, there it is. R's alone. There's the answer. R equals 10 over 8 cosine theta plus sine theta. We got r alone. We changed from an xy equation to an r theta equation with r alone. We changed to a whole nother system. Is that good? This whole other system? Questions on that one? All is good?
So we don't have to.
That's it. That's what they want you to type in, is all of this.
Do we actually have to find the theta?
No, it's a relationship. So it's an equation, it's a relationship. There's several r's and thetas that fit. Just like the xy, there's several values for x and y that make that true. Several values for r and theta. It'd be a... Okay, same thing. They want... yeah. So get... change that to a polar equation. Try that one. So you know what to plug in. Same old thing. Every time you just plug in. What do you plug in for x? What does x equal? R cos theta. And y is r sine theta. So just plug that in for x. Plug that in for y. And do whatever cleanup you can do. So you're going to get r squared cosine squared plus r squared sine squared is 36. Are we good so far? See what I did there? I just plugged in the x as r cos theta, plugged in the y as r sine theta, squared the x, squared the y, which means squared the r, squared the cosine, squared the r, squared the sine. Now what could we do? What could we factor out? The r squared. So take out the r squared. They have r squared in common, right? It's the GCF. Good to there.
Is there a way that you could take the square root of both sides?
Hold on. We will eventually, but first. Yeah, we will. You're right, Kevin, in just a minute. But first, we good to there? Everybody see what I'm doing? I'm just plugging in the r cos and the r sine, squaring everything, because the original equation is x squared and y squared. So I just squared the r cos and squared the r sine, right? Now, then took out the GCF, what's in common. Now, what is this? Anybody recognize or remember? What is it? 1. Yeah, remember? Sine squared, remember that identity? Plus cosine squared is 1. Whenever you find sine squared plus cosine squared, that's 1. So that's r squared times 1 is 36, meaning that's r squared is 36. Isn't that nice?
That means r equals 6.
Yeah, and then we can square root it. R is 6. That really cleaned up. That whole equation right here is the same as r equals 6. Isn't that surprising? All right. Okay, let's take a look at this one. It's going to be the same thing. This one's going to have a little trickery to it, does it? I don't remember exactly. Let me just go through it with you. So same kind of thing, right? What is x always? r cos theta, right? Just same old thing. You just keep, every time you got x, that becomes r cos theta. Anytime you got y, that's r sine theta. Okay, good so far? So x becomes r cos theta, y becomes r sine theta. Now, how do we square r cos theta minus x? What do you do when you got a 2 on a parenthesis? Write 2 of them, huh? So I'm going to write r cos theta minus 6, r cos theta minus 6, plus, this is r squared sine squared. Good so far? So this guy's going to go boom, boom. We good? R cosine hits R cosine. R squared cosine squared minus 6r cosine. Good so far? How are we doing? Am I going too fast? Is that making sense? I just took that r cosine and I multiplied both those. And then this minus 6. So minus 6r cosine plus 36. Everybody good with all that? Plus r's. Whoa, come on, I thought I changed colors there. This comes to here, this comes to here. We good? Everybody good with that big old, this big old mess right here all came from these guys, huh? Let's gather some like terms. What I'm going to do, look at this r squared cosine squared and this other r squared sine squared. You know what they're going to do? Exactly what they did a minute ago. I'm going to take r squared cosine squared and put right next to it r squared sine squared. And then in a minute, I'm going to factor out the r squared. And cosine squared plus sine squared is 1 and vanishes, huh? Just what I did a minute ago. Now, in the meantime, the other two, what is minus 6 r cos theta and minus another 6 r cos theta? Minus 12 r cos theta plus 36 equals 36. We good there so far? So I just gathered like terms? Okay, so now we'll do what we said. R squared, factor it out. Cosine squared plus sine squared. Minus 12 r cos theta. Now what about the fact that we have 36 on both sides?
We just subtract the 36.
Yeah, just subtract 36 from both sides. Equals 0. Right? Just gonzo, gonzo. We're getting close. And then what is cosine squared plus sine squared? 1. So this is r squared times 1. It's just r squared. Minus 12 r cos equals 0. What form do they want? They want r alone. Okay, we're close. A couple more steps. Everybody good so far? Ready for a fresh screen? This is like 2 steps away. So r squared minus 12r cos theta. So everybody good today? Everybody tracking with all those steps? Now, they want r alone. They want you to get r. How do I know that? I just looked here and I said, oh, they want r alone. So they want r alone, so I'm going to jump this to the other side. Becomes positive. Whoops. And to get r alone, do you see what I'm going to do? Divide by r. There it is. R is alone. 12 cos theta. R equals 12 cos theta. That really cleaned up, didn't it? Will that come to the casual student who studies 5 minutes before the exam? They will fail. So this is just more and more feel the burden to communicate clearly to college math science students taking, these hard classes. It takes time. You've got to give it your life. Give it your life. It takes a lot of practice. That's not easy. Questions I can answer. I am glad to help. I am eager to help. Anything I can help with? Come see me, see Wendy. All right, so y squared is 4x. So here, I'll just get a fresh screen here. So y squared is 4x. Same thing, we want to change it to r theta. Give it a go. So you know what? What is y? Our sine. What is x? Our cosine. This one will be easier. So that's r squared sine squared. That's r cosine. Good so far? Now what could we do with the r's? See, I'm just going to divide by an r on each side, and that leaves only one r on the left. You see that trick? Just like I did last time? When you have r squared on one side and a single r on the other, just divide both sides by r, and you get the r almost alone.
So it's not bound by the Costco rule?
Yeah.
Costco's plus and minuses. There's no plus or minuses here. Yeah, good question. Pluses and minuses can't. There's no plus or minuses here. Guillermo.
Still sine squared.
Oh, thank you. Good to there? Now, what do they want? They want r alone, notice. What do you got to do to get r alone? Divided by sine squared. That should have been sine squared. I messed up. Guillermo's right. Sine squared. Boom. So then r equals 4 cosine theta over sine squared. Now, on a multiple choice test, like we will take next Monday in a week, they might have an answer like 4 cotangent theta cosecant theta. Would you recognize that that's the same answer?
Yeah, because copies, right?
How do you know, Jamie?
It's like cosine over sine is cotangent, right?
Yes,
And
exactly.
then 1 over sine is cosecant.
Yeah, everybody see what Jamie's saying? She's right on the money. Basically, what they did, the book likes to do this kind of thing. They took that cosine, they said, let me put that over one of the, let me separate the two sines on the bottom, the sine squared, into two separate like that, and make it two separate fractions. Cosine over sine is cotan, 1 over sine is cosecant. So that's the same answer as that, huh? So would you recognize that in a multiple choice exam in a week? Your skills have to rise to that level. That takes time. Is that good? And they want you to change to xy. So we're going to change that r equals 4 to xy. Now how do we do that? Well, what you're going to also want to have in your 3x5 card is the conversions, which we've already used. What is r equal to? Square root of x squared plus y squared. Remember that? I think we called it square root of a squared plus b squared. Or I squared plus j squared. Same thing, x squared plus y squared. Right? And theta, which we won't need on this one, is tangent inverse of y over x, huh? So use those two conversion equations. So what am I going to plug in there for r? Square root of x squared plus y squared equals 4. So I'm converting from r's and thetas, really we just have r, to x's and y's using these conversion relationships. Anytime you see r, you can replace that with square root of x squared plus y squared because it's equal to the square root of x squared plus y squared. So I do that. Now what do they want? Y alone, x alone, what do they want? They just say type an equation. So probably they'd want you to get rid of that root. How can I get rid of that root? If I 2 power both sides, it'll cancel that root. Remember how 2 power is the opposite of root? They cancel each other out. So then that'll become x squared plus y squared is 16. There we go. Now, do you remember from your algebra, intermediate algebra, algebra 2, math 3, whatever it is, class, what that's an equation for? No, don't remember. X squared plus y squared is r squared is a circle equation of radius r.
Yeah, no, I don't remember that.
No, not at all. So this is, let me just go back to making this 16 into 4 squared. So that's a circle of radius 4.
The whole circle has
It's a circle of radius 4. Yeah. So you need to know that now. When you see x squared plus y squared is r squared, that form is the form of a circle equation. Yeah, we did that in 103. So put that on your 3x5 card if you don't already know it. That's a circle. So what they're saying is, hey, when you took this and changed it to that, remember, they're saying remember, they're assuming you remember from your early algebra classes that that's a circle equation. That's a circle of radius 4. That means this r equals 4 is just circle of radius 4. So which one is it? Which one of those answers, A, B, C, or D? D, because see the jumps are 2, 2, 4. The radius is 4 on D. At B, the jumps are only 1. That'd be only radius 2. This one would be radius 2. This one is radius 4. The answer is D. That good? All right, so number 20. Let me bring it over here for us. Theta equals, what is it, 11 pi over 6? 11 pi over 6, yeah. Theta equals 11 pi over 6. They want us, again, change to xy. So how do we change that to xy? Remember I gave you the two change relationships. R is the square root of x squared plus y squared, and theta is inverse tangent of y over x. So what am I going to do with that theta right there? Theta, you're the same as inverse tangent of y. Remember, it's inverse tangent. That's an important distinction. We get to there? Good so far. So I'm going to take another step that might surprise. I'm going to bring it down here and rewrite it in preparation for my surprise step. I don't know, won't be a surprise to some. Will be to others. We good so far? So theta is inverse tangent of y over x. You know that one. We've used that one quite a few times for vectors and now for polar. Anyway, so they want me to get, probably want me to get y alone. Yeah, they do. See, on number 20, they want y alone. You with me? See, they want y alone. So how do I get y alone? Y is here saying, I want to be alone. Get this tangent inverse off of me. Get this x out from underneath me. I want to be alone. So how do we do that? How do we get that tangent inverse off, first off? Regular tangent. Good. Regular tangent. But whatever you do to one side, you got to do to the other, right? Two things are equal. You treat them the same, they'll be equal afterwards. And these will cancel. Tangent and tangent inverse are opposites. So that gets rid of it, doesn't it? So that gives y over x. It doesn't cancel on the other side, though, because, you know, there's just one of them, right? There's not a tangent and a tangent inverse like there is on the left.
Do we use degree mode or radian mode?
I'm just going to go to the unit circle. 11 pi over 6, that's on my unit circle.
Is that 330 degrees?
11 pi, there it is. So 11 pi over 6, cosine sine. So the tangent, let me bring it up here. So tangent of 11 pi over 6 is, remember, sine over cosine? Tangents over sine, always sine over cosine. Sine minus a half over cosine, root 3 over 2. We get to there? Grab that root 3 over 2 in the bottom, dividing is upside down, multiplying, flip it up. Minus a half times 2 over root 3. 2's cancel, minus 1 over root 3. I'm going to leave the root in the bottom for now. Maybe I'll fix it later, whatever. Everybody good there? I found the tangent of 11 pi over 6. Sine over cosine went to the unit circle. Negative a half over root 3 over 2. Flip it up. Cancel minus 1 over root 3. Bring it back. If we all got that down. So this is minus 1 over root 3, isn't it? Let's bring it up here. So we've got y over x is minus 1 over root 3. So far, so good? Where are we at? What do they want? They want y alone, please. Y alone, please. Let me get this out of the way. I need a little more room. We're almost done, but I need a little room. So y over x is minus 1 over root 3. Okay, so what do we do to get y alone? I'm going to cross multiply. There's a couple things you could do. Root 3y is minus 1 times x. Last step, just divide by the root 3, huh? Or I could have just multiplied by x up there, huh? Yeah, I should have done. What am I doing? You don't need to cross multiply. That's kind of dumb. Let me just go back. Sorry. Just multiply both sides by x, right? Boom. Y is alone. Minus 1 over root 3x. Now, they probably won't let me leave a root in the bottom. They might. I don't know. So multiply top and bottom by root 3, as you know. Minus root 3 over regular 3x. There we go. We changed the theta equals 11 pi over 6 to an xy equation. Look at that. Then we got y alone. We good with all that? Questions I can answer on all that?
So how's the graph going?
Oh yeah, let's go look at the graph. Yeah, you tell me. What kind of graph is that?
It's going to be a line.
That's linear, isn't it? That's y equals mx plus b. That's a line. That's a slope. That's a line going down, isn't it? Because it's got a negative slope.
Yeah.
Right? You guys know about graphing lines, right? Plus 0 is out here. The y-intercept is 0. Goes through the origin. When x is 0, y is 0. And the slope is negative. Down. It's a line going down through the origin, isn't it? Let's go back. Number 20. So line going down through the origin, A. Good? Questions I can answer on that one? So we did that. Theta was tangent inverse. Took tan of both sides. Found tan 11 pi over 6. Multiplied the x. Okay. Same thing. Changed to xy. Remember our conversions? X is our cos theta. Y is our sine theta. So this one's cake, right? This is a piece of yummy cake. Easy, easy, easy. Our cos theta, what's that? This is x. X is 4. Done. Next question. Right? Piece of cake. Now, oh yeah. Mr. Heron is kidding us. No, it's true. Because x is our cos theta. Let's move on. What does a graph of something like x equals 4 looks like? Goes through the x-axis right at 4. A line going straight through the x-axis at 4. Right? Line goes straight through the x-axis at 4. Do the same trick. You remember the conversion relationships. X is our cos. Y is our sine. Give you 30. So this is 6 over sine, right? Because cosecant's 1 over sine. Is that too fast? Right, that's what cosecant is, right? Sine on the bottom. We good there? Now what? Put this over 1, diagonal, diagonal. R sine theta is 1 times 6. R sine theta is 6. And what's R sine theta? Y equals 6. What's the graph look like? Through the y-axis? Up at 6. Straight through the y-axis at 6. Good. Moving on. Okay, so here again, they want me to convert to xy. We remember the conversions. R is cos theta. Y is r sine theta. This one has some tricks. Basically, if you haven't seen it, you wouldn't think of it. It's kind of a trick. Was everybody good right now? So I want to change to x and y. Let me give you a second. Maybe get more out of it. Okay, so this right here is like almost x, huh? It's got the cosine, but what is it missing? The r. If I could just get an r in there, then I could swap that out and put it in x. R cos, I can replace with x, because x is r cos. Anytime you see r cos, that's x, right? Think, well, I see a cos, but I don't have an r. There's no r there. If I could just get an r there, I would have r cos, and that's x, right? So could I put an r there? If I do both sides. See, that's the trick. You got to multiply both sides by r. This side becomes r squared. The other side becomes minus 18r cos. Say you put an r on both sides. You can always do the same thing to both sides of an equation, right? If two things are equal and you treat them the same, they got to be equal afterwards, don't they? So now, what is this r cos? That's just x. And what is r squared? What's r? Square root of x squared plus y squared, remember? So this is square root of x squared plus y squared squared, which will remove the root, and so it's just x squared plus y squared is minus 18x. Did you track with that? Because we got a little bit more to go. But are we good to there? Now comes the real trickery. That they would consider the easy part. Do you see that? See, how did I know to do that? Because I needed an r next to that cos theta. Because r cos theta is x. So I multiply both sides by r. The r cos theta became x. The other side, r is square root of x squared plus y squared. Right? Squared, so it removes the root. Right? That square was already there. I just put it there, and it canceled the root. Okay, now, the trick is if you look, you think, why isn't that it? We got it. We're xy now. Why aren't we done? Yeah, I mean, you're right. We are xy, but they're being real picky. They want multiple choice, and they want those forms. How do you do that? Well, something tricky, which they assume you remember, but I know no one ever does, called completing the square from algebra. You've got to complete the square. So I'm going to move this over here. And go x squared minus 18x plus y squared is 0. So you get that like that. And yeah, it's like a trick. Basically, what would be the easiest way for me to show you the trick? Yeah. Yeah. So here, let me bring it over. I want to show you the trick without wasting too much time. So basically, okay, so here's our equation, right? X squared minus 18x plus, I'm just going to bring it over so we can look at the options. Look at the options for a minute. A, B, C, D. Which of those looks like it's even possibly right? Let's go through it one by one. How about? Could it be this? Could it be A? And what is x plus 9 quantity squared? Let me bring that down here. What is x plus 9? That means x plus 9 times x plus 9, right? Which is what? X squared plus 18x plus 81. Do we have plus 18x?
No.
No, not A. Could it be B? No, they have a plain x squared. I don't have a plain. I have another term. No, not B. Could it be C? No, they just have a plain x squared. I have more than plain x squared.
Why don't we have?
Not A, B, or C. Could it be D? Could it be x minus 9 squared? Yeah, that's right. Because if it was minus 9, you see, it would be minus 9, right? And that would be minus 18x in the middle. And it'd still be positive 81 because 9 times 9 is 80. Two negatives is positive when they multiply. So it'd be right? Yeah, but we don't have the 81. We don't have the 81. Right. But see how they also have an 81 on the right, wrong one. On the right side? So what could I do? Add 81 to both sides. Right? It's going to be the same as my equation. Anytime you take an equation, do the same thing to both sides. You haven't changed it. That'd put an 81 on the right side. That would put this 81 right here. Yeah, maybe I should add it right next where it really belongs. Right here. That would give me x squared minus 18x plus 81, which is what the x minus 9 squared would be.
So, Mr. Heron, I
D.
have a question.
Yeah.
The 18x, when it was on the right side, it was negative, right? So when you moved it, it didn't change to positive?
Show me.
'Cause, right?
Oh, you're right. Kevin, you're right. That should be plus. Tell me that stuff earlier, man. Plus 18. Good job, though. Thanks for telling me at some point. Yeah, that should be plus. Right? What are you guys doing just letting me do that crazy stuff?
You were just checking to make sure you know.
That's right. So yeah, that should be plus 18. So that should be, so we want the plus 9 one. So we do want A. We want A, actually. Yeah, thank you. Not D. It's A. Because it's plus. It should be plus 18. Thank you. I messed up. Thank you. It should be the plus. We want the plus. Good. All right. This. Yeah, multiply through by an R, right? Why? Because I want to make R cos and R sine because that's X and Y. It's getting a little more predictable. It's kind of the same tricks every time. It really is. X is R cos, Y is R sine, yet again. So multiply this side by R, and this guy, and this guy. Just multiply all three of them, right? That's fine to do. Whenever you have an equation, you can multiply both sides by the same thing. They were equal before, and you treat them the same. They got to be equal afterwards, right? And we're trying to change x, y again. The whole point of the game here is to change to x, y. So 5r cos plus 3r sine. Keep going. What is r cos? Well, let me let you do more of that. Okay, so what is r cos? That's x. R sine, that's y. And what's r squared?
X squared plus y squared.
Yeah, because r is the square root of x squared plus y squared. Therefore, r squared is plain x squared plus y squared. Isn't it? Right? So this is x squared plus y squared. This is 5x3y. Okay, the trick on this one, bring this over, bring this over. Remember to change signs. Don't do what I did last time. Right, they become negative when they jump to the other side. Right, Kevin? I wish you'd remember that. Right, we good there? And then let's go to the thing. What do we got? X squared minus 5x. Oh, they make me do the whole thing. Oh, this is too bad.
How do you know what the graph looks like?
Yeah. 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 All right. There's just no getting around it. All right. You ready? I'm going to go to fresh screen. I thought we could just kind of half complete the square. Like I just had. I said, just look. You can tell. No. They're not playing games, which they shouldn't. It's true. Students should know this. I know they don't, but I'm telling you, you want to do STEM. You got to learn a lot of stuff. You got to know how to complete the square. You're supposed to know it coming in the door. I'm sorry if your teacher didn't teach it to you, or I'd love to do it with you in office hours to great extents. I will do it. I will help you, but I only have 3 minutes, and here we go. You take the middle term, you put it over 2, and you square it, and you add it to both sides. You do the same thing for the y. Put it over 2 and square it, and you add it to both sides. It's called completing the square. It's an important concept in intermediate algebra. But my pre-calc students don't ever remember it either. I know nobody remembers it, but the truth is it's supposed to be covered earlier. So that 25/4 and that 9/4, what did I do? I took the middle number and I put it over 2, and then I squared it. That's what you do to find the magic, what's called the completing number, and then you add that to both sides. What do I mean add it to both sides? I mean you literally write plus 25/4 here and plus 9/4 there. But whatever you do to one side, you have no choice but to do the same thing to the other. You've got to add the 25/4 and the 9/4 both to the other side also, right? We can't change anything. And then these 3 are guaranteed to factor as a square. We just completed them. We just gave them just what they needed to become a square. What do they need? The number in the parenthesis is the number in the parenthesis. That's x minus 5 squared. This is y minus 3 squared. The other side, 25 and 9, 34/4, which is 17/2. There's our equation. What is that? That's a circle. The other thing they assume you know coming into the class, that's a circle whose center is adjusted by these two. Adjustments next to x and y in equations of this type always have the opposite effect. This is right 5/2. This is up. It's the opposite of what you would think.
So it's going to be a circle.
So it's a circle whose center is right and up. It's a circle in the upper right-hand corner.
It's the negative, we do the opposite of what we think.
Because what you would have to plug in to get 0 is actually positive 5/2. So the 0, 0, the new center, positive, positive, actually, right and up.
So if it's at x plus 5/2, we go
Left, yep, it's opposite. It's always opposite. So it'd be the upper right-hand corner one, which would be that one. There it is. All right.